All right, I want to talk about three types of natural selection. So this shows you traits of a mouse. So fur color in a mouse can range from very light to very dark. And you can see here there's a bell curve that most are in the middle. So these are numbers. Very few have dark fur, very few have lighter fur. Most are sort of in the middle, sort of this brownish color. All right, so this is the normal curve, and you would find this as far as variation. Remember, variation is necessary for natural selection to occur. You would find this for most anything. If I did human height, there are some of us that are very small, including me, some of us that are very tall, but most of us are somewhere in the middle. All right, so any trait, hopefully you find a bell curve like this. All right, so what can happen over time? So this one down here, we'll start with this one on the left. Basically what happens here is that this white arrow shows you that those that are on this side of this bell curve, sort of these lighter colors, are not surviving very well. So only the darker colors are left to survive. And over time, when only the darker colors reproduce, this is this dotted line, my bell curve moves and shifts to the right, because here was brown before. Well, now that sort of middle color is getting darker because only the darker ones are left to survive. So this is called directional selection because my curve is moving in a direction. Obviously, if the darker colored ones were not surviving, then it would shift in this direction over time. So I would say that this is probably one of the more common types of natural selection, is this directional selection, where it moves in a direction because some of the ones on the edges, on the ends, are surviving better than the ones on the other end. Okay? So this one in the middle is called disruptive selection. Oops, I can't spell. Disruptive selection. And what happens here is, so these ones that were here in the middle, the brown ones, they're not surviving. So you can see this arrow. The ones in the middle don't survive, but the lighter colored ones and the darker colored ones seem to be surviving. So for whatever reason, those lighter colored, those middle colored ones, those brown ones, are not surviving. So what you see then is that I get an abundance of lighter colored ones. It goes down in the middle because the brown ones aren't surviving, and I have an abundance of darker colored ones. So this is called disruptive selection because you can see it really disrupts your curve. It goes down in the middle. And if these become separated from these, this can lead to new species. So, if these two don't reproduce anymore, this one may become a new species and this one may become a new species. All right, the lighter colored, the darker colored ones. All right, so that's disruptive selection. So that's when the middle does not survive as well. And the last one over here on the right, this is called stabilizing selection. And stabilizing selection, here are the arrows. My darker colored ones are not surviving very well, and my lighter colored ones are not surviving very well, but my middle ones are. So only my middle ones are left, my medium brown ones, and you can see that my curve goes up in the middle, and my curve is shorter. I've lost variety here, all right, because it stabilizes the middle. The middle ones are surviving the best. All right, that's stabilizing selection. A good example of this is human birth rates. There are some that are born with very low birth weight, some that are born with very high birth weight, but it seems that this middle birth weight seems to be the best able to survive. So probably most of you were somewhere around 7 or 8 pounds when you were born, probably 6 to 8. There are some that are 10, there's some that are lower than 6, but most people fall in that range because that's what survives the best. All right, so stabilizing selection is where you lose variety because only the middle ones are surviving. All right, so that's 3 types of natural selection.